So, our third emergent property said that water tends to expand upon freezing. And why is that important? Why would we care that water expands when it freezes? Well, to think about that, we have to start looking at the insulation of bodies of water by floating ice. Okay, so if water expands when it freezes, basically that means that it's going to become less dense than the liquid water that surrounds it. And in essence, that means that ice floats, right? So the first arrow says solid water or ice is less dense than liquid water and therefore floats in liquid water. And the hydrogen bonds in ice tend to be more ordered, right? They're just more structured than they are in liquid water, which is what contributes to the fact that ice floats or the fact that ice is less dense than the liquid water. But this is great, but why do we care? Let's find out on the next slide. So, when we think about icebergs or floating frozen water, we have to think or consider the fact that underneath frozen water is liquid water, right? So, if you have a pond and let's say it's freezing outside and that water froze, what would happen if it sank? So, let's say the top layer of our water froze and sank. That means that the cycle's just going to continue, right? So the next layer of top water will freeze, that will sink, and eventually our entire pond would freeze. Well, that's a big problem for any animal or plant or any living organism that's in that water because it's eventually going to freeze as well. So what ice does on top of water is that it kind of provides insulation to all the organisms that are below it, right? Some people like to go not deep sea fishing, ice fishing, and they can, crack through the ice and start fishing. And that's because those animals are able to survive under that layer of ice. So this illustration says, in ice, each molecule is hydrogen bonded to four neighbors in a 3D crystal. Because the crystal is spacious, ice has fewer molecules than an equal volume of liquid water. Okay, basically what I want you to get from this is that ice is less dense and basically becomes a barrier that protects the liquid water below. And it says the marine organism here, which is a type of shrimp found under the Antarctic ice, is able to survive. So by the expansion of water when it freezes, we get this protective layer that protects all those other living organisms. And what's really interesting is that most liquids, when they freeze, they become more dense. Water is one of the few exceptions. Now, another emergent property is that water is the solvent of life. So what is a solvent? Well, let's first break down these four little bullets, and then we'll give you an example. And this is kind of the best example I've come across. But when we use the term solution, I think everybody has heard this term, but what exactly is a solution? It says a solution is a liquid that is a completely homogeneous mixture of two or more substances. Okay, well, what is a solvent? We said water's the solvent of life. That simply means that it's some sort of dissolving agent, right? So water is going to dissolve different substances at some point. Our third arrow says we have to consider something called a solute. And it says a solute is a substance that is dissolved. So water, in lots of situations, is going to dissolve different types of solutes. And so let's think about those little flavor packets you can buy at the store these days so that your water tastes more interesting. Okay, you can go to the store and you can buy just many different flavors. Okay, well, what happens is you take a sugar packet. Let's say we buy like a strawberry sugar packet. Okay, that's going to be considered our solute. We're going to dissolve it in our water. And our water, again, is going to be the solvent. Well, once we've mixed those two together, we're going to get the creation of this solution. Okay, it's just going to be kind of a homogenized mix of our solute and solvent. And in science, whenever you're talking about water as being the solvent, you would call that an aqueous solution. So again, water's really important, okay? If it's the universal solvent or the solvent of life, Basically, that means that those different regions of the polar water molecule are able to interact with different types of ionic compounds, again, many of which we call solutes, and it's able to dissolve them. So I think a really important example of that is the fact that we're continuously having to take in water as a living organism. And that's because of the fact that our body produces different types of ions and we eat different types of foods that may be salty, and we need to be able to break that stuff down and dissolve it. And water's the reason we're able to do that. So this last slide just illustrates, and kind of wraps up what we just discussed. But in the top picture, you see these little red and white molecules, and those are our water molecules. And you can see that they can break down different types of ions. So in this example, they're using sodium chloride, which sodium chloride is just salt, right? It's kind of like our table salt. So water is able to kind of break down those solutes and eventually turn it into a homogeneous solution, right? And I want to leave you with this slide, which I really want everybody to kind of burn into their memory because it's something that we're going to talk about over and over again in this class. And those two terms are hydrophobic and hydrophilic substances. Okay, so first let's break those words down. Hydro means water, right? So at the first bullet, we see the term hydrophilic. Okay, half of that word means water, but if you were to look at the meaning of philic, you would find that it means it's has an affinity for something, or it's loving. So if you break that word down, it means water loving. Okay, so any type of hydrophilic substance is a substance that can interact with water. Okay, it has an affinity for it. Well, the opposite of that is something called a hydrophobic substance. So let's break that word apart. Hydro again means water, and phobic means fearing, right? If you have a phobia, you're afraid of something. So a hydrophobic substance is something that does not like to interact with water, right? So it's kind of considered water fearing. And there's lots of both of these examples that you find in nature, but just keep that in the back of your mind and understand the difference between a hydrophilic and a hydrophobic substance.